Hi, everybody. So now we're going to work in the laboratory, and we've collected our standard KHP, and we've determined that the mass of the KHP was 0.6185 grams based upon our weighing by difference exercise we've just done. And what we're going to do in this experiment, very similar to what you'll be doing in lab, is we want to standardize a sodium hydroxide solution. Now, the bottle lists it as 0.1 molar, but our goal is to find out precisely to 4 decimal positions what its molar concentration is. So we take our standard KHP, and we're going to prepare for our titration experiment. Now, one thing we could do is we could just use a scout like I've suggested and like many of you will do. Now, for the standard KHP, we actually can approximate the volume by doing a calculation. And we can only do this for the standard because the standard is almost 100% pure. So I wrote up some information on how we can estimate the volume for a titration experiment. And what we're going to do is we're going to estimate the volume of a 0.1 molar sodium hydroxide, given that we've weighed out a certain amount of KHP. The mass of it was 0.6185 grams. And we would be able to determine the number of moles of KHP simply by taking the mass that we've weighed out and dividing it by the molar mass that would be given to us. And that would tell us the number of moles of KHP that have been weighed out using the method of weighing by difference that we did a few minutes ago. So notice that the titration for KHP and sodium hydroxide, it's a nice easy 1-to-1 titration. What we mean by a 1-to-1 titration is that for each mole of KHP that's present, 1 mole of sodium hydroxide will react with it. So if we know the number of moles of KHP that we've weighed out, we know when we get to the equivalence point, which is the point in the titration in which we have stoichiometrically equivalent amounts of acid and base for an acid-base titration, that tells us that at the equivalence point, the precisely 0.003028 moles of sodium hydroxide will react. Now, since the concentration is approximately 0.1 molar, then we can determine the approximate volume to reach the equivalence point by taking the number of moles of sodium hydroxide that we calculated and dividing it by the approximate molar concentration. And we're able to estimate our volume. We're going to approximately need 30.28 milliliters of sodium hydroxide to reach our equivalence point. So this is nice to approximate it either using a scout, and I've explained that in your simulation, and it's also explained in the procedure, or we can calculate the approximate volume. And what this tells us is that we can probably add about 25 milliliters quickly, and then slowly add until we reach the end point in the titration. Notice I used the term equivalence point here, and now I just threw out the term endpoint. There is a difference between the two. The equivalence point is where we have stoichiometrically equivalent amounts of acid and base in an acid-base titration. The endpoint is the point in the titration in which an indicator and a dye that we're going to use is phenolphthalein changes colors. There's a physical change in that environment. Typically, we choose an indicator that's going to have an endpoint that's going to be about the same place as where our equivalence point is. So let's move now to the actual titration. I have it set up, or started to, over here. So here's how you're going to be working in the laboratory. You're going to have your burette and a burette stand. And you would clean out your burette. Now your burette has scale markings It starts at 0 and it ends down here at 50. So when we read a burette, we read the burette from top to bottom. And we can estimate, based upon the scale markings, to the nearest 100th milliliter. In other words, if I read this, I can estimate it to 0.01 milliliters. So we're making our estimations to give us 4 digits total, or 2 digits past our decimal, when we make our estimations using the volume in our burette. So what we're going to do is we're going to get our burette ready, and we're going to place some of our 0.1 molar sodium hydroxide in the clean burette. And we're going to do that by using our burette funnel. Now, our burette funnel is the funnel that has the short spout on it. I'm going to use a plastic one just to be safe here today. Put it in there, and I'm going to add my sodium hydroxide. And when I add my sodium hydroxide, I'm going to make sure I have a waste beaker underneath, not any samples that I'm working with. So I'm going to put in some sodium hydroxide. And I'm only going to put a small amount in for the time being. Yeah, unfortunately, this one's not working. So that sort of sucks. Get a different one. Stop. And strength. Okay.